In June 14, 41 variant, question number 6, and topic is Newton law and pulleys. Okay, so we have given here two particles, A mass 0.25 into 10, so it becomes 2.5 newtons. So 0.75 into 10, this becomes 7.5 newtons. So naturally, intention towards pulley is clear. Heavy particle will come down, so it travel downward, it will go upwards. So what happens, and because your eye is, observer's eye is here actually, okay? If observer's eye is here, what happens, so the particle coming towards speed is negative and this is a positive. So positive is above x-axis, this is a positive, okay? And negative below x-axis. So I always say when we have this kind of thing, because it is going away, so it's a positive speed. So this is lighter particle. Above lighter particle and down diagram is for the heavy particle. This is a clear sign. Logic is only one. Because coming back to I, speed negative. Going away from I, speed positive. And speed positive here. So this is a particle A actually. This is a motion full diagram for A particle only. Not for B at all. Okay. So first he asks acceleration, not a hard job for us because this is coming downward. So let's talk about B. This is coming downward, so this is a bigger force. 7.5 minus tension equal to MA. And for A, it goes going up, so this bigger force, tension minus 2.5 equal to MA. Tension cancel, and I got here 5. And here I got a 1, so acceleration is 5 meters per second square. First part is over. And you know very well in velocity time graph, the gradient is equal to acceleration. And the area in the graph is the distance covered. This is very clear. Okay. What is the situation? Actually, I tell you very clearly. Particles were moving down at once when this is a level when string breaks. So string breaks. So string breaks at this level, Up till this motion, we have this acceleration. But as string breaks, this is called free fall upward. I write here free fall upward. Free fall upwards motion. Clear? So this is going. Can I say that this triangle I will divide in two categories? See? So this area is this distance. This area is this distance. Okay. And I think so we can find easily, we can find this velocity easily. How come? Because at this point the coordinates is x 0.5 comma v. And here 0, 0. So let's go for the acceleration formula. Y2 minus y1 over x2 minus x1. And acceleration I have 5. So I copy here 5 and y2 is t minus 0 and x2 is 0.6 minus 0. Okay. So when it goes there, so time is become 5 times to 0.6 and I got a time is 3 seconds. So I think it's clear. 3 seconds you got it?
Velocity.
Sorry, velocity. So I got velocity. Thank you very much. This is the velocity. X coordinate 0.6 and y coordinate is v. Sorry. So this is a v. Okay. So it means this is a velocity, and velocity is coming 3 meters per second. So this is the first part is over, and I got velocity. Now question here, what is g? If you look at try to compare, is going up and stop. So this is called free fall upward. It means I can find it. Okay. Do you know what is the last speed of this motion is equal to starting speed of the next motion? So I think I can say here this v I'm writing here for a free fall upward. Free fall upwards. So let's data. This v become u and gravity going upward, free fall negative 10 and last speed confirm 0. I want to find the time. So v equal to u plus gt, last 0, speed 3 and negative 10 and time becomes 0.3 seconds. But this is a 0.3 second and 0.6. So I got 0.9. So I can say here that capital T is 0.6 plus 0.3 give you 0.9 seconds. So this is my answer, it is over. Let's talk about this one, okay? Now he's asking here, first of all, find distance by the particle A upwards, then A downwards, and then try to find H. So can I say, look toward my hand, this distance is the area of this triangle, this distance area of this triangle, I think clear. So if it's very clear. Now, problem is what here, you can see here, and this distance we can find from here. This is a full distance from here till the ground. So let's find it. And this distance we can find easily. How come? And for, okay, this distance let's find. So upward distance. So distance upwards. So distance upwards. So we can find half into base into height. Base is 0.3, height is 3. So base is a 0.3 and height is 3. And you got one answer. So 0.9, 0.45. Check. Half into the, okay. And similarly distance. Show me. Distance 0.45 seconds, okay, meters. So distance downwards now. So downwards distance is this triangle area, because this distance is this one and this distance is this one. So let's find this distance. So that is a, sorry, I have to find this one is a 0.6, sorry. Upward is a 0.6 and distance upward 0.6, okay, and height is 3. And I got what answer? 0.9 meters. Now this is called free fall upward. Free fall upward, okay? And that is a half into base of 0.3 and height is 3. This is 0.45. I think clear. Can I say this distance total is those triangle area? Correct. So going upward. So going upward, total distance. So add them 0.9 plus 0.45, 1.35 meters. Okay. Now I want to find this distance, and luckily I have time. Okay. So let's find it now. Let's start on the top. It will start downwards. Let's talk about the other one. So free fall downward now. Free fall downwards. U0, because starting from here. U0, gravity plus 10, and time it will take, how much time here? 0.9. So 0.9, and how much this gap? 0.7. So time is 0.7. Find the distance. So I can say S is equal to UT plus half AT square or GT square. S is, we have to find this 0, half time to 10 into 0.7 square. Give me this one. 2.45. So my question, this is 2.45 and these two is 1.35. So repeat again. This is 1.35 and this total is a 2.45. So from full subtract, I get H. So H is equal to 2.45 minus 1.35. 1.1 meter. And that's it. Repeat again for you. This distance, add them both, is equal to 1.35. And this falling down from the top to down is to 2.45. So from 2.45, you will leave this part. So get this side. This is called H. So that's the way we can get answer. That's it.